Hi, everybody. Welcome to the St. Louis Angular Lunch. We're here hosted at Oasis Digital, where you do Angular Boot Camp, for anyone in the stream who has not heard of that. Today, we're going to have Jack Balbes talking about laziness in testing. And I'm going to assume that he means laziness in a valuable technical sense, not in the sense of don't bother to test. But who knows? I haven't seen this talk yet, so we'll see what happens. Here at the Angular Lunch, we try to focus on intermediate to advanced topics. But we are also working really hard to promote a St. Louis evening Angular meetup that Paul Spears here has adopted recently. On that, he focuses on kind of introductory to intermediate topics. So I would encourage everyone here, tell all of your friends to please go show up there. It does great topics. It's a kind of evening. It's a little bit more festive than we are here. So don't forget that. And I think we have, or talk to Paul afterward if you're here and you don't know how to find that information. He'll get you a link. So Jack, take it away.
So welcome, everybody. Thanks for being here. So as Kyle said, it's important to understand the kind of laziness that I'm going to be talking about. And so to qualify that here, I'm talking about laziness in terms of the three virtues of a great programmer. As Larry Wall put it, laziness is the quality that makes you go to great effort to reduce overall energy expenditure. So the idea here is that we're going to be working smarter and not harder in order to get good testing coverage of our application. So that's one term that we kind of need to clarify in this title here. The second term is actually in that testing part, because in an Angular application, there are actually generally two different things that you're going to be talking about when you're talking about testing. You're going to be talking about unit testing and end-to-end testing. And in this talk, I'm primarily going to focus on unit testing, but I'm also going to mention end-to-end testing and use that to inform some of the decisions that I make with my unit tests and what I choose to write. So for my example application here, I have just taken a standard Angular CLI application and added a very small feature to it, which is two inputs that I can put something into, and then it goes back to a server, updates the server, and then updates the view. So the basic maintenance loop of, scroll up, or bigger size, okay. So the basic loop of an application of displaying information to the user, getting some input from them, sending it back to the server, and then displaying the results to the user. And for this very simple application, there's actually a lot of unit testing code that we can write. And I know because I wrote all of it. And here's my proof. So here, the CLI actually comes with code coverage tooling that you can just turn on and have. And we can see here that in this application, I actually have 100% code coverage in my unit tests. I have gone through, and even though it's a very simple example application, because we're focusing on testing, this is the important thing to talk about and look at, and so I have gone to the effort of doing that. So let's actually take a look at some of the pieces to this application. So let me bump this up a couple spaces. So in our application, the starting point for retrieving our data is going to be our data service. So in my data service, I have a number of different methods that I can use to go and talk to the server. So I have just going and retrieving some data. I can go and retrieve data based on other data that I've gotten, or I can based on other data that I've gotten, I can, and then I can send some data back to the server to make some modifications. Now, the tests for this are actually longer than the code that I wrote. So the service that I wrote is some 35 lines long. The tests are 70 lines long, which is actually kind of ridiculous, because if you just kind of follow along with the tests as they're generated for you by the Angular CLI, you're going to end up with a lot of extra stuff and extra work that you're doing in order to test very simple things. So if we take a look at our test, the first thing that we do is we create this testing module, right? So we're actually setting up kind of a fake Angular environment for doing our testing in. And we're also bringing in this HTTP client testing module. So this is a tool that Angular provides that allows us to mock out the HTTP service, which is important because that's fundamental to everything that our service is actually doing, right? Every single one of these methods has an underlying call to the HTTP service or HTTP client service. So in our tests, right, we go and we get an instance of our service. We get an instance of the HTTP client that we can use to control what is happening in our application. And then we go through and we're going to test bit by bit each code path in our service. So the first one is just make sure that it can be created. This is what's generated for you by the CLI. And then for each of our methods, we have an it block, which is going to go ahead and call that method, get back an observable. It has to subscribe to it. And then it needs to actually control the HTTP client in order to control what happens behind the scenes and make sure that that's all happening as expected. So in our first test, we're just expecting that if we ask it for some data, it will hand us back that data. For our next test, we're asking it to get the data in a particular format and then testing that it came back in that format. And we keep going with this, right? So we're getting data based on a second HTTP request. So here we have to actually control not one, but two HTTP requests in our test. And then finally, we need to test that when we send data back to the server, we hand it some data, it formats it correctly, and then sends off the right thing. So here we're saying, okay, please, send back this data, and we're going to expect to receive back from the server this value, and we're going to expect that you will have sent this particular value to the server. So that was all a lot of code and a lot of talking for tests that don't actually test all that much. So let's take another look at this service. So what all does this service actually do? What is this code actually that we wrote? So in the case of this get data method on line 17, if we really look at it, really all that we're doing here is calling the underlying HTTP client, right? And the point of our tests is not to actually test the HTTP client that is already very thoroughly tested for us by the Angular team. We don't actually need to do that. And the only way that this really could fail our test that we've written is if this string, right, becomes incorrect for whatever reason. And it's kind of silly to write a test for a method just to make sure that a string is correct, right? A string inside that. And in fact, really what we should be doing is just having this in a constant. So I'm actually going to do that right here. So I'm going to refactor it to a constant in the module. So this is my API URL, right? So I'm going to use that throughout my service. And what that really means is that this method isn't really deserving of a unit test, because if we apply a little bit of reasoning and think about what this test is actually testing, right? So this one right here, this is just testing that the HTTP client worked. That's not a valuable test to write. It's not really a valuable test to run. So we can go ahead and eliminate it. So then looking at this getting data and formatting it method, in this method, again, we're starting off by just calling the underlying HTTP service. We don't want to test that because it's already something that's being tested by somebody else. Really, the thing that we're doing here that's worthy of a test is this calculation right here. Well, as the code is written, right, we need to actually call the method in order to run this code. But that's actually really easily solved, because if we just extract this function to the module scope, so and it actually didn't quite do it the way I wanted it to. Actually, So let's just take this and we're going to extract it to a method up here. And we're going to say, calculate URL equals that function. And we do need to do a little bit more typing here in order to make it completely applicable. But now, in order to test this code, we no longer need actually a copy of the data service. So in our test, what we can actually do is we can pare it down to, instead of calling this get data and format it, and then subscribing to it and going through all of the work of managing an HTTP request, we can take this line of code here and extract it out. So now we're expecting, what did I call it? I called it calculate URL. Of our test data to be the value that we expect. Oop, and it's because I don't export it. So the lesson to learn here is that when we're looking at our application and thinking about what tests we want to write, we want to think about not only what is the underlying thing that we're testing, but also how can we potentially refactor our code in order to make it more testable. So this is why a lot of libraries, for example, like NGRX exists in order to make your code written in such a way that is more testable in this fashion. And this applies even in other scenarios. So now we have a much more reasonable test for what we're actually doing in this method. So then following along with that logic, this get data based on another HTTP request. What are we actually doing here? Well, we're calling get data and format it, which we've already unit tested. So we don't need to unit test that again. And then we're using RxJS, right, to just map this data, right, and call the API based on that. But really what we're doing here is we can think of this as almost like a configuration, right, where, assuming that switch map works correctly, right, this code isn't actually doing anything new. It's not doing a calculation. It's not going through any kind of branches. There's really nothing that we wrote here that's doing anything. So we can really actually ignore it for the purposes of unit testing. So that's a whole nother section of code that we can delete. Then finally, our send back some data method is in the same boat, right? Where we're just sending some data through this HTTP post method, and assuming that HTTP client works correctly, which we are because we trust the Angular team, then there's not really a good way. The only way that this could potentially error is if this calculation here actually throws an error of some kind. So in this case, it's a relatively simple calculation because this is a simple app. But in a real application, you could imagine that we might have many different parameters to this function, and we have some complex logic putting those together into a package to send them off. So for this example, we want to extract this to a function. So we're going to say something like export calculate data for server, and we get two inputs, thing 1, which is a string, and thing 2, which is also a string, and then we're going to return that calculation. So we use that then in our method. And now all of a sudden, the thing that we actually want to test in our unit tests, once again, doesn't actually rely on the HTTP client. So in our test here, right, we're expecting that the request body is the right thing. And so instead what we can do is we can just call this method. So calculate data for server of thing 1 and thing 2. And then we can get rid of all of this other stuff. Okay. So now we've gotten our tests down to the point where they're roughly equal in size to the service that they're actually testing. So that's a pretty big improvement. And then we can realize that actually the things that we're testing here, right, the method, these methods, those are, actually not reliant on this test bed at all. So, because our service doesn't actually do anything on startup, right, it just injects some stuff, we're actually pretty confident that Angular is able to instantiate a class and pass it a parameter without some errors, right? So what we can actually do in this case is actually eliminate this before each, right, and just directly test these methods. So what we've done is by applying a little thought beforehand for what we want to write in our unit tests, we've actually been able to extract out the essence of the code that we wrote and test that, as opposed to testing our framework. Okay. And then our service essentially becomes just something that's putting all of those things together, right? It's taking these smaller bits and putting them together. And if we wanted to test that, that would be something more like an integration test, right? It's actually a higher level test than a unit test. Our unit tests are focused on one thing at a time, not putting those things together. And we're actually covering our integration tests with the end-to-end tests, right? So an end-to-end test is the ultimate integration test, where we're taking all of these things and putting them together. So when we're thinking about our unit tests, we can eliminate those tests that we look at and we say, well, actually, what we're testing is putting together all these building blocks that have been handed to us by other people, right? So in our service, we have a little bit of logic regarding how we communicate with the app and then the server. And so that is the thing that we need to test, not how we actually put it together. So then putting it together is tested in our end-to-end tests. So if we take a look at those. So in our end-to-end tests, so I've left the built-in end-to-end tests here. But the big thing that we're looking at is this test right here. So this is the test that actually goes in and is going to put some values into the screen. It's going to expect, that those things update in the view, right? So if we look back here, right, it's going to type in something right here, and it's going to expect that it then updates in the view. And then it's going to just refresh the page and make sure that that data actually got persisted to the server. And so what this is going to do is it's going to exercise all of the code that I decided not to test, right? So in my data service, those paths that I'm using, right? So sending back data, getting data from the server, all of these things are being exercised by my end-to-end tests. And so if I put these together wrong, my end-to-end tests are the things that are responsible for actually catching that error. So let's take a brief look at some of the other pieces of our application, because our data retrieval service is only one of the kinds of things that we're expected to unit test in an Angular application. So for example, I also have a small state management service here. And this state management service just uses a subject as its method in place of something more complex like NGRX. So it has one method that just accepts the new value of the data and then calls .next on the subject. And then it provides back an observable, which is the result of the current state. So we start off with calling our data service. So this is going to initialize our values. And then we also have this other observable pipeline that takes those updates, it debounces them, and then it sends them back to the server to update, and then comes back with the result. So what this is going to end up being, this data observable, is an observable for the current value of data. And then we tack on at the end a share replay so that people can come along and subscribe and not have to go and refetch the data or wait for the data to be fetched by some other means. It just is available all the time. So my unit tests for this are actually, again, much more complex than the actual code. So if we have 50 lines of code for my unit tests and 25 lines of code approximately for my actual service implementation. And the reason for that is because of the dependency injection right here. I have to mock that out. Because of this debounce in here, I have to then take direct control of the clock in my unit tests. But really, if we look at what this is doing, I don't actually have any of my own code in here, right? This method here actually is just calling through to a subject, right? This is just all calling through to either, my service that I'm mocking out, or to my or to RxJS. And so really, what is it that we're actually testing here? Because if we look at the unit tests that I wrote, so we go through, we create a mock that we can use to control the data service. We have some initial values that we can set. We set up our test bed. We go ahead and inject the test bed. We get our service via dependency injection. We check that it can be created. And then we go ahead and we subscribed to that data observable. We tick the clock to make sure that it sets the current value to be the initial value. We update it with a new value. We tick the clock long enough in order to have that change propagate through RxJS. And then we expect that the new value has come back. But really, this is kind of deceptive as to what I'm testing here. Because when I am actually making changes, right, I'm calling back through this send back some data method, which is mocked out, right? This debounce is coming from a library, which has also got its also being tested. And so really, like, all of this code is being either tested in some other place or is being mocked out by the test that we wrote. So the only thing that we're actually testing in this test is the fact that the timeout worked. So really, what we can do is we can delete this test. And the reason, did I delete the wrong thing? I think I might have deleted the wrong thing. This is why we have source control. Yes, I did. Or, no, I didn't. It looks like it didn't actually delete. I deleted the wrong test. That's what I did. That's fine. So if I delete this test, the right test. So, and the reason that I'm able to do that with confidence is because in my end-to-end tests, I'm actually exercising, once again, this service. I'm exercising the integration between all of those parts. And so I'm able to, with confidence, assume all of these parts individually work. I just need to test them all together. So I said that this wasn't about end-to-end testing, but really those end-to-end tests are important because they're allowing me to be lazier in my unit tests, because I don't need to write integration tests in my unit tests. So a similar concept applies for our components. So in the default application set up for the CLI. They generate unit tests for your components, but especially with the components that I have here, right? This is my top-level app component. All it has is one property. And by default, you actually get a lot of tests for this. So here, I'm testing that it can be created, and then you're testing that the title was set properly. But again, let's think, what is this actually testing? This test is actually testing that Angular worked, right? That Angular was the thing that was taking the value, taking and setting the title, and it was the thing that was setting the value of this h1. So really, right, I don't want a unit test that, this binding worked, because that's not a good test, right? It's testing something that's already tested elsewhere very thoroughly. I don't need to write it. So we can go ahead and eliminate this whole swath of testing. So we have a few more components that we can take a look at, but again, most of these components are actually going to be fairly thin, right? So my top-level smart component, right? So in Angular we have this idea of smart versus presentation components. My smart component, its job is to arrange other components on the screen and then communicate between them and a service. So in my spec, right, I can go in and I can make sure that it is able to be created. I can make sure that if I trigger an event handler of a child, that it updates my service, right? But again, what am I really testing here? I'm testing that the Angular application, the data flow worked, right? Which is more of an integration test. So the fact that this component, really all it's doing is calling through to other things, right? This component isn't actually a unit, right? It's not a good unit for unit testing. So we can, once again, eliminate a whole swath of tests, right, as something that is being tested elsewhere by either our end-to-end tests or by the Angular framework itself. So then finally we have two display components, right? We have our component for actually putting the data on the screen, which again, just like our top-level app component, right? All we're doing when we test this is making sure that this input worked, right? That's not really a good unit test. We don't want to waste our time making sure that Angular works, so we can go ahead and remove this test, right? There's a whole bunch of work that's being done here to actually go in and set the input and then make sure that Angular detected the changes and then had set the inner text correctly, right? All of this, again, testing that Angular works. So we can delete that. And then the last component we have, we're avoiding doing any kind of state management ourselves by using the reactive forms. So here we have this form group for these two inputs that we then connect to the screen right here. And then for our inputs, or for our output, we just take the value changes observable. And because outputs can just be observables, we're just handing that back to Angular and saying, here is the stream of changes coming out of this component. And then for the input, all we're doing is calling through to the form to set the value. So once again, this component is not actually doing anything itself. It is just a collection of other units that are already being unit tested. So one more set of unit tests that have to go through this complex process of setting up a testing module, compiling components, going ahead and setting a value, and then making sure that the form has the right value. But again, we're just testing in this case that this method worked. Well, that's part of Angular reactive forms, so let's not test that, right? Let's think about it and realize this is not actually a thing we need to test. So again, deleting it. So what does that leave us with in terms of unit tests? Well, not all that much actually, which makes sense because this app doesn't do all that much, right? And so our data service, yeah, that was the one thing that I actually deleted. So if I actually go through, let's check out here. So, so this is just checking out a point where we're at the same spot. So all of our unit tests, right, boil down to this bit right here. Because in my whole application, the only thing that isn't basically putting other units together, right, isn't putting together, you know, a basic component with a template and maybe a form, all of which are things that are well tested by Angular, is happening in this surface. And this is something that you'll often see in your applications where, you know, the thing that is actually doing work that's actually complicated is, you know, in your service or maybe in like a pipe, or it's in a function somewhere, right, that you can just test as a function. So the takeaways from this, right, understand, you know, what it is that you're trying to test. Don't test your frameworks, and don't be afraid to refactor your application in order to make it easier to do those first two things. And that is laziness with testing in Angular. So, questions? Yes, I think we've got a mic coming for you. So,
thank you for that. So can you give some examples of things that would be beneficial to testing? I'm assuming like maybe if you're transforming the input or something along those lines.
yeah. So when I was actually making this talk, in my data entry component, I actually went back and forth as to whether or not this qualified as something that required a unit test. Basically, you know, does checking and seeing if something is a undefined count as actual logic or a calculation? And in the end, I erred on the side of no. But if we were doing anything more complicated in this set, right, so transforming the data here, that would be a good candidate for unit testing. But again, you know, if I was doing that, I would encapsulate that in a function that I would call here, and I wouldn't test this component, I would test that function. So similarly, you know, if you think about like pipes, for example, right, would be another good place where you'd probably find a rich set of things to unit test, because they are essentially, you know, functions that take input, transform it, and then you know, hand it back to somebody else. And so by definition, they're going to contain calculations and logic. So, yeah.
I was wondering when you would test something like an RxJS pipeline, for example, in your service.
Mm-hmm.
Would you ever want to test what happens if that initial data call takes longer than when you get your first update on the subject?
Yeah. So.
Like the merge operator in it?
Yeah. So, by, you know, in this talk, I've kind of intentionally written a simple application to kind of hammer home the point that a lot of testing that you think you need, you don't need. But in that case, right, the case you describe where you have where the pipeline behaves differently depending on what happens, then that might be a good case where a unit test is justified. So just because, you know, all of this tooling isn't here, you know, just to make, you know, a bloated code base. It is actually useful. It's just a lot of times used more than it should. So there are definitely cases where you would want to do something like that, but only if your pipeline actually has behavior in it that is not extractable from the fact that it is a pipeline.
I have sort of some fundamental objections to some of the techniques you were using, in that in a philosophical sense, I consider unit testing to be testing of a unit, and in those cases, most cases, that's going to be like the class.
Mm-hmm.
And a class we consider to be a behaviors that are coordinated together, right? And there's a public API, and then there's the private API. There's the private parts of that class. And what I saw you doing was extracting some internal implementations into things that you made public in order so that you could test them, which I understand, and I've been apt to do that often myself, but then you're sort of conflating what is the public API of the class and what's the identity of that class. And furthermore, since we have the functions are sort of your public functions are your API for your class. When you have it seemed like you were looking at a lot of the implementations and saying the implementation is simple, and it is already doing things that are tested, so I don't need to test that. But your implementation may change over time, and there might be details. So it seems like you want to have tests for those things, even if the implementation at the time you test it is simple, because it could become more complex.
Yeah. So when I'm talking about going through and eliminating these tests, I'm talking about them in terms of what the code currently is. So if my code gets more complex, it might make sense to put that back in, right? And like I said, with similar with the RxJS pipelines, if you have something that is complex enough that it warrants a test, right? Test it, but don't just test it because you're trying to get 100% code coverage. With regards to testing the classes as a unit, I guess that's kind of a philosophical discussion as to what you consider to be a unit in unit testing. And so, you could define the unit to be the class, but that then brings in all of the complexities that we had at the beginning of the talk, where you have to go through and do a whole bunch of setup in order to instantiate that class and instrument it in order to determine what's going on and control it. And so the idea here is that by kind of lowering the level of our unit tests a little bit, we can actually save on a lot of that boilerplate by focusing on these functions essentially. So that's kind of a philosophical difference. If you have if you have a reason, like a strong reason why this class needs to be unit tested as a unit, then that's something you can think about. But by default, you shouldn't think, oh, this is a class, it needs to have a unit test, is what I'm saying.
Yeah, so Jack and I work very closely on all these things together, and he and I are pretty much of one mind on it. And so there's something else I wanted to add to that, which is all of the advice that Jack's presented is steeped with like two underlying premises that have nothing to do with code, and that is pragmatism and value. At the end of the day, these unit tests, they should be providing business value to your clients and or your employer. And you have to weigh that with the business value of meeting the deadlines, meeting the feature time pressure. And so, in a perfect world, yes, we're going to have 100% test coverage of all of our things. But when it comes down to the wire and you've got to choose what gets cut, everyone knows that tests usually often get cut. And so if you're looking at this from a pragmatic standpoint and as a value proposition, what's more valuable, making sure I've gray box tested this unit class, or I've written an end-to-end test that will ensure that the product owner's business value is retained despite revision, which one is going to add more long-term value? And if you only have time to write one, which one do you do? I think that kind of is the underlying premise to everything that Jack is getting at here.
Yeah, and that's why I iterated. I'm making these decisions with the knowledge that I have end-to-end tests in place already. And so I kind of already have that high-level integration test that I can rely on for putting all these things together.
Okay, I want to share my soon-to-be friend in Purple's bemoaning of the language features, that there's not like a word you can put in there that says expose this for the purpose of testing but not production code. Like, become a language designer and make that language, and I will help adopt it. But my question, Jack, is kind kind of a softball. So, like, what if it turns out that Angular data binding just doesn't work right? What should you do about that? Should you go write a bunch of tests that your Angular data binding work? Like, what do I do if I'm worried Angular data binding doesn't work?
Well, if you have a reproducible, error in Angular data binding, you should go and open an issue in their issue tracker, right? Because fundamentally, that's the Angular team's responsibility to fix.
What if it still doesn't work? What if they just won't make data binding work?
Yeah, move to React, or yeah.
That's the answer. It's a highly competitive market. If the platform you're using on sucks, move.
So I think the gist of this seems to be to move a lot of your tests up to the integration and E2E level. I was wondering how that works with code coverage. Do you get automatic reporting of that when you no longer are testing a lot of methods in your classes?
So is there a way to do automatic code coverage for like end-to-end tests? I'm not aware of a tool that does that, but I'd be very interested to hear about it.
Yeah, so I guess I'm pointing out that you're not going to get code coverage reporting for a lot of your code now.
Mm-hmm. Yeah, and actually if I run my tests, we can actually look at what the code coverage looks like. Because it just automatically generates them when I have it set so it automatically generates the code coverage results when it runs the tests. So if we just give it a minute here. Okay, so then if I look here, so now we have, let's see, we do have 100% of branches. So what we would need to do is we would need to, take a look at this and see if there is some kind of metric that we can think about where it's like, okay, well, I haven't tested, all of my functions, but I have tested, I guess it's saying branches 0 of 0, so I guess that's not a good example. My functions, you have to have smarter code coverage tools that can understand, when a function is mostly just calling through, or when a function is entirely calling through to other functions. Yeah.
Although I'll point out that when you reloaded, you lost 2 of your 4 folders. The way that code coverage works by default is that it will only show entries for files that it actually executed. So that 100%, 68% are 68% of the files that the tests actually touched. That's 68% of all your files.
So that would be a lot more uncovered stuff then.
Right.
I can answer part of that too. Is this on? Yeah. So you talked about moving stuff to integration tests and to end-to-end tests.
Mm-hmm.
For integration tests, you typically run those with the same machinery that you run your unit tests, and so your code coverage is no problem at all. You're already going to have code coverage and coverage reporting. If you really want, and if you want to do code coverage of like your end-to-end tests, you can. There's nothing stopping you. You just have to do a few more steps by hand. It doesn't like ship that way by default, like it ships that way by default for Karma. But there's no reason you can't. I mean, all it's doing is annotating your code and setting flags of whether the code ran.
Yeah, I just want to make a comment. I don't know what it's called, but as far as the exporting functions from a class, there's a fixture component or something where you can access private functions from the tests and just the tests. So it kind of can overwrite that in some tests. I'd have to look it up. It does exist though, and that's a way to avoid the sort of security holes or whatever that you have there with the public functions.
Yeah, I think how you do that is you have a separate TS config for your test environment that doesn't care about a thing being marked as private. It just is able to then access it.
On a previous project, my coworker and I used to do that, but then they changed the tsconfig rule, so there was no way to say, let access to private things go through, but if I completely typo a function name, also complain about that. I don't know, maybe they've tightened it up since, but at one point, like if we wanted to turn that off, we lost all type checking whatsoever in our tests, so it wasn't worth it for us. But maybe that's better now.
Did you have, I saw your hand go up earlier. Did you have more comments or?
I just want to make a point that all of the code that Jack extracted into functions that are now globally available are all pure functions that have no side effects. So there's really very little risk of it doing any damage to the rest of your application. If somebody else wants to use that function, whatever, right? And he's testing that, he's testing it as a pure function with an input and an output, to verify that it always does the same thing. And again, it's not going to affect the class that it was originally in. It's not going to affect your application state. It's a pure function. So if other people want to use it, so be it. It's no longer, yes, it's no longer part of the private implementation of that class, but doesn't really hurt anything by moving it out as long as it remains a pure function that does not actually modify the state of your application.
All right, well, thanks everybody.